we need to fit line y equal kx plus b to our data set x and y, with special conditions that intercept should equal 0. To doing this, we need to find minima of the function L, which depend from k and b, and this function is equal sum of square distances between predicted and our data set, which is k x plus b minus y squared, with b equal 0. So now let's open the brackets and see what will happen. So it will equal sum from k squared x squared minus 2 kxy plus y squared. And we need to find the minimum of this function. To doing this, we should take partial derivative of this function L over the k parameter. And it will be equal sum from 2kx squared minus 2kxy, and it should be equal 0. So let's open the brackets. 2k sum of x squared minus 2 sum of xy equals 0. So we can cancel 2, and once again k times sum of x squared equal sum of xy. And now we can derive k from this equation. So the k equal sum of xy divided by sum from x squared. Let's load standard PyCharm environment with included NumPy, matplotlib libraries, and the template for drawing function. First of all, we will start with fixing random seed and then create linear space for drawing straight lines, which is enough only 2 points from -1 till 12, which will be our range of drawing. So x will be a random set of dots in the range from 0 till 10. So we will take 50 dots and multiply this random value by 10. And y will be x multiplied by random value again to make it even more random, and add 1 just in case to remove from 0. So first of all, let's calculate the coefficient kp and bp from Polyfit function from NumPy. So we need to supply our x dots, y dots, and say that we would like to use a straight line or power 1. And let's print out the results. So we will write it in form of equation yp equal kp times x plus bp, where kp and bp is our coefficient. And now let's calculate k according to our equation. So it will be sum of x times y divided by sum of x squared. And let's print out this equation as well. So it will be y equal k times x minus plus 0. So and now let's draw these functions. So first function we draw as it is, and second function we will draw a straight line with coefficient kp and bp calculated by NumPy function. And label will be RMSD between this function and our data set. So we need to write function to calculate RMSD as well. So we will supply our y and predicted y value. And we will plot it with accuracy 3. So now let's make function RMSD. So let's look at this equation and let's use this equation. So we'll take y1 and y2, and then so we will take y1 minus y2 squared Then we will calculate mean value, and then we will calculate square root from this mean value. Everything with NumPy function, and return this value. Okay, and now let's plot our function with zero intercept. So just minor changes in this plot, and let's do color black, and label as well will be kx, just kx, and again accuracy 3. Let's see the results. So we can see that coefficient is slightly different and lines are slightly different, and of course fixed line is slightly worse with our RMSD. But this is our task to find this line.